Hi, everybody. I just wanted to tell you how to do the assignment that you have to do on today, May 3rd. Um, yeah, you're here with Mr. Um, Ben, and I just wanted to give you a quick overview of what I want you to do for the assignment. So, the assignment is in Canvas, as always, and then click on it, obviously. Go to Assignments. And the assignment is called Analyzing Food Webs. Analyze a food web. So we're going to click on that and make sure that you link up. And for me, I'm just going to open it up from here to show you. All right, so this is a Google Doc. It has several pages, and on each page, it has a food web. So the first thing you need to do for each page is, in which type of ecosystem might you find the species in the food web above? You're going to answer that right in the box beside it. Here's a diamondback turtle, a horseshoe crab, and a clam and plankton. So I'm pretty sure, oh, by the way, it says marine ecosystem. So this could be ocean. What else? Could be a salt marsh, at least a little. Yeah, I think these things could be in a marsh because they're all small enough. And then it might even be in an estuary. All right, so some marine ecosystems. All right, the next thing says list 3 possible abiotic limiting factors that could theoretically impact this food web. All right, so abiotic means not living. And then limiting factors are factors that prevent reproduction, growth, health of different ecosystems or different populations in the ecosystem. So I'm going to say something like this: the saltiness. I spelled it wrong. I did spell okay. The saltiness of the ocean. You could say salinity. That would be better. That could be one. Let's see what else could impact them. The amount of sunlight they get down in the water, how deep the water is. And then how about the temperature of the water? Remember how we learned that colder water is better able to absorb and dissolve um, gases. So water that's too warm would have a lot of trouble with the holding gas. So temperature. Okay, so it can be anything that could be limiting to these guys, but I wanted you to stick to abiotic things to focus on those. All right, now the next step is this. You got a little table down here, and it's like this. If this population increases, striped bass, right? So I'm going to go back up and look at the striped bass. All right, so if this population increases, then what is a population that will decrease because this increases? So I'm thinking if this increases, then there's going to be fewer snowshoe crabs, right? Because the eater of the snowshoe crab is the striped bass. So the, let's see, what did I say? The horseshoe crab. The horseshoe crab. Okay. And then think about this. Anything that eats the horseshoe crab, if there's too many striped bass, then these guys that eat the horseshoe crab, all 3 of them are going to have a decrease in population because there's going to be not enough horseshoe crabs for all of these guys who are depending on them. So that means you're going to have to put the grackle, the sanderling, and the razor clam all up in there. Okay, the razor clam, the grackle, I spelled clam wrong, the grackle, and what else? The sanderling and the loggerhead turtle. So it looks like a lot of people, a lot of creatures depend on those horseshoe crabs. And what was it, the turtle? Loggerhead. So a lot of things would be impacted by a huge increase in your striped bass population. So what population might increase as a result of more striped bass? So let's see. If I have so many striped bass, right, then I make this decrease. Oh, wait a minute. The razor clams. Ew, ew, ew. Oh, no, no, no. The horseshoe. Oh, I see. The razor clam shouldn't have gone there because the razor clam would increase X. So razor clams go there. Oh, what did I do wrong? Okay. All right. See where I messed up, guys? Right here, the razor clam. The arrow is pointing to the horseshoe crab. So the horseshoe crab eats the razor clam, not the other way around. And that means that if there are fewer horseshoe crabs, right? Because this is increasing, because the striped bass increases, there'd be fewer horseshoe crabs, which means there are going to be more razor clams. So that means the razor clam population would increase. And if the razor clam population increases, then also that would mean that there's more food for the turtles. So what was that? The diamondback turtles would also eventually increase. So it's just a matter of thinking about how one organism's increase or decrease affects others. Let's go to plankton. Plankton down here would be basically your producers, especially the phytoplankton. So anything that when it decreases, it's going to mess up everything. But if it increases, everything is going to do better. So basically, if plankton increases, then everything increases. I'm going to just say it this way, all populations. And if plankton increases, nothing's going to decrease because of that. So no populations. All right, so I'm not going to do any more, but there's another page here. Now keep in mind, it looks like it's the same as this page, but see where it says population increases? Down here is going to be these decrease, and then you're going to tell how it impacts the other ones, other populations. All right, then you have a totally new one here where you have to tell which type of ecosystem you might find in these species in, and 3 possible abiotic limiting factors, and then you're going to analyze the food web, tell what would increase and decrease if these populations increase, and what would increase and decrease if these populations decrease. So it's tricky. And then you've got a third set. I actually got fourth. So you're going to be super busy today, and your job is to get as much done as you can. All right, so you've got actually several different sets to work through, but you've got a long class period too. All right, I'm going to sign off for now. Remember that if you're finished with this, that you should check everything else on your slide for today's lesson plan, and just make sure that you have everything that you need done. Please use your time wisely, be good to Mr. Ben, and have a great weekend.